Hey, welcome back to another MassTransit live coding video. I'm bringing some more of the content that we started yesterday. I was going to say I was bringing some, yeah. Anyway, trying to freshen up my intro again. No, not really. Um, Yesterday was great. We did 2 episodes of season 3. I thought maybe there would be a bunch of people sitting at home on New Year's Day just kind of chilling, and maybe the timing was right, so the time slot worked. So we're back today at the same time slot. I don't expect as much today. It's a Saturday, but we had some of the highest viewer numbers. We had like 16 concurrent viewers on the live stream yesterday, and we've already had, I think, over 80 views on the YouTube playback. So definitely some great response. I think everybody's, holiday weekend and just, trying to, find something to do. It isn't like there's any parties going on outside or anything. And if they are, they're being harassed in the media for not following the guidelines of everything that's going on. So I wanted to kind of just recap where we're at. We did 2 episodes yesterday. We created a consumer. We created and then we moved that to routing slip activities. And this season is all about orchestration and choreography. We're really trying to build like a real application. And so I'm not going to recap too much. The videos are there. You can definitely watch them. But I wanted to jump back into something yesterday that kind of gave me an irritation. And it has to do with, when we were looking at RabbitMQ, I made the comment of when I had the activities set up, it had the default underscore execute. And since I have kebab case formatting for all my endpoint names, I was really irritated by that. And in the essence of kind of cleaning it up and making it my own, before the show, I kind of went in and said, this is my project. This is, me as a company consuming MassTransit, and I want to really make it so that this is my stuff. So I created another extension method called apply custom MassTransit configuration. And inside here, I go ahead and I set a custom endpoint name formatter. I was using the kebab case formatter out of the box, but I thought to myself, I can fix that. These extension points exist for a reason. So I put the existing formatter inside of my class here. And then I'm just kind of overriding some of this stuff. And for these 2 cases, I'm overriding the execute and compensate activities. And by default, we don't sanitize the name on these after the extension or the suffix is added. I just added a call to sanitize name because what that's going to do is any underscores, it's going to convert them to dashes. So that'll give us a nice clean thing in the broker. Now if I go and run this, I go back and look at RabbitMQ once it's all started, I'll see it create 2 new queues with the nice dashy names. There's the dash execute, there's the dash execute. So now I can go and delete these old ones. They're just on my development instance anyway. And now I have the consistency that I wanted. So again, just taking advantage of the extensibility to kind of make this my own thing. Yeah. The other thing I did is because I know that because I know I'm going to be using the request client, by default, you'll notice this long named endpoint here, Mac Pro, fork join API bus with a base 32 encoded GUID. That's the bus endpoint. The bus endpoint is where responses come back. It's created by every bus, but it isn't auto-started by default. And since I haven't hit the endpoint yet, I haven't hit the HTTP API to make a request, normally this queue would not exist yet. But I went ahead and told it that I wanted to auto-start it because I know I'm going to use it and it can eliminate just that tiny bit of delay on the first request. Plus, it goes ahead and just makes sure it's started. So if I hit the health endpoint on here, so if I change this to health/live, I think it's, well, I have to spell health right. I should get the JSON data out and this is something I've configured in the startup config to output the health endpoint, but this gives me the status of all my endpoints. The status is healthy, the bus is healthy, all the endpoints have been started, nothing is degraded, so all the endpoints are up and running. And it gives me that visibility so that I can check that. Great. I just wanted to kind of cover those 2 housekeeping points before we jumped into it, because we have a lot to cover today, so it's going to be pretty cool. Yeah, I'm pretty stoked. So we'll go ahead and stop that. I'm going to leave RabbitMQ running in the background. I'm going to continue to run this with F5 because I feel like that gives us kind of the best experience for kind of jumping through things and seeing how it all works. Hey, Albert, welcome. Yeah, so where we left off yesterday, we had the consumer, the submit order consumer, was creating the routing slip to execute the activities of grilling the burger and then dressing the burger. And we were building the routing slip in the consumer. And if we kind of play this back from the way it worked yesterday, and I'll run this one more time. Built should come up quick. We're all connected up. We got our test endpoint. The one thing to remember from yesterday when we ran this is when we ran the order and we submitted it, this completed right away, but it's still running over here. We're grilling it, the grilling is still going on, we dressed it, and all of that was happening in the background. So we've kind of changed the dynamic. The burger isn't done within the request. And recognize that you wouldn't have an HTTP request waiting for the however long it took to grill a burger, or in a larger system, however long it took to pick, pack, and ship an order. But we're using that metaphor to kind of show how we can take these existing patterns and put them into the scale of a large, choreographed system that we want to compose together. So I'm going to stick with that, but I want to get back to that behavior that I had. I don't want the request client to complete until I've received and completed the order of the processing of the burger. So that routing slip that executes with those two activities, I want to wait until those are done before I complete the request. So if we look back in the request order, or the submit order consumer, here is where I'm checking to see if a response is requested. And if a response is requested, that's when I need to think about how I want to handle this differently. And I'm going to do this first raw right in the code. When I execute the routing slip, that happens asynchronously. Those activities run in the background. And I know from having worked with MassTransit for a long time, obviously, there's two values that have meaning. There's two values that have meaning in a request. There's the request ID, and there is the response address. Those are the absolute minimum required for it to know that it's a request and it needs to respond. And most people just write respond. They know it's request response. Here I'm checking just because, why not? So yeah. Then the other thing I'm thinking of is there are two other values that actually could be interesting. One is the fault address, because if a fault happens, I want to, so someone's in the chat asking about NAT streaming. I don't know what that is, sorry. So I have to ask in Discord or somewhere. This probably isn't the right place to ask. The request ID, response address, and the fault address. The fault address really just overrides the response address if you want faults to go somewhere else. But by default, if there's a fault in a request, the faults go to the same address as the response address as specified. All right, so now that I have these details of what I need to have, what I want to do is I want to make it so when the routing slip completes, I get these I use these values to somehow produce the output back to the requester. Because if I take this out, the request client will time out. And that's what I don't want to complete the request at this point. So I'm going to think about, so I'm building the routing slip and I'm going to send it. But if you recall, I'm adding some variables down here to the routing slip. And I'm doing that with the submit order. Because I'm going to need access to these headers, I'm going to change this argument type to the full consume context because I need more data. And I will change this to context.message.orderID. And then I'm going to take these properties or these headers that I know are useful, and I'm going to add those as variables to the routing slip. So I'm going to say builder.add variable, and I'm going to say request ID, and I'm going to say context.request ID. I'm going to add context.response address, and I'm just going to call that again the same thing. And then I'm going to add context.fault address, or not message, but context.fault address. Checking the chat here. Yep. Okay, so I'm going to add those as variables to the routing slip. They get added as their types. because I want to save this information. I want to be able to use this later on down the line. Now I need to change that. And I'm going to stop sending this response. Well, I'm going to save that line for a second because I'm going to leave it there. So now I'm going to create the routing slip. I'm going to execute it. And I'm adding the request information to the routing slip. Now, I know that the routing slip produces two events, routing slip completed and routing slip faulted. And I know that because I've read the documentation. No, I know that because I wrote it. So I'm going to add another message type here. And I'm going to call this the routing slip completed. Because right now we don't have any faults. Fault handling and compensation I'm going to do in the next episode. But for now I'm going to focus on this. So I'm going to add another method that's going to consume the routing slip completed event. And when that event is received, I'm going to use the information in that event to determine if I have the request information and send a response to the original requester. So basically, I'm just decoupling the consuming of the request to the producing of the response, because it doesn't matter. It's an address that I'm sending a message to. And I can do that from any component in my system. So I'm going to break that out, and I'm going to say, okay, well, when I get a routing slip completed, I am going to say request ID equals context.get variable, message.get variable. And I know it's a GUID. And I know that its name is request ID. And I'm going to do this for the other two properties as well. I'm going to get the response address, and I know it's called response address. And I know I could use name of response address here. In fact, I probably just should do that. Consume context dot response address. Great. And I should probably do the same thing in here. Request ID. And I should probably do the same thing in here, fault address. Because again, hard-coded values, they're always terrible. Question in the chat, timeout for request if routing slip takes too long? Good answer. It will time out at the client. I don't have to actively manage the timeout on the server side. The request client will time out if the request doesn't complete in time, like if the routing slip takes too long. Yeah. We'll get our fault address. And these are URIs, so I need to change the type here so that I get the request type. And this is just going to deserialize those variables from the routing slip's working memory and put them in here. So now I can say if request ID.hasValue and response address is not equal to null, I need to generate some sort of response. And yes, I realize that I'm submitting order submission accepted, but we're going to stick with that message type for now. Oops. So we know we have a response address. We'll make our method async. We don't have a context.message order ID, so that's something else we have to yank out of the routing slip, because remember, we added the order ID as a variable right there. So we will get that. I don't think these dictionaries are case sensitive, so it really shouldn't matter, but anyway. So we're just going to put order ID in there. I know in the case of message initializers, they aren't. Which I am using the Roslyn analyzer for MassTransit, so I can just tell it to add the missing properties, and then I can just say it equals order ID. Okay, so I'm going to respond, but I can't respond because remember, this consume context was sent by the event producer of the routing slip completed. So I need to change this up a little bit. I have a context, and in this case, I'm going to say context.getSendEndpoint response address. And what this is going to do is let me then send that response directly to that endpoint, which is exactly what MassTransit is doing under the covers when you do a respond async. So now we're just going to do send endpoint, or actually we're just going to rename this to response endpoint. And we're going to call send. And it turns out that we need to also set some headers. So we need to set the request ID header because that's how the request client is going to correlate the message back. So I'm going to set request ID equal to request ID.value. And I think that's the only one I have to set. I don't have to set anything else. I'm not using the fault address because a fault didn't happen, so I guess I don't even need to read that, but it's there. And if I have a request, I'm going to send the order submission accepted. I'm going to set the order ID, the request ID, and all is going to be well. All right, let's try it. Why not? Syntax is green, so it must work, right? So now this should wait until the routing slip completes before my Swagger request simulator completes. Is it running? Did I leave it running? I left it running, so we'll start it over. I always forget to leave stuff on running. All right, we're firing up. We go back in. Let's go take a look at what RabbitMQ looks like right now. So I have my submit order queue, and I have some bindings on it back to the exchange. But you can see now I'm getting that MassTransit courier contracts routing slip completed event. So that event has been bound to my queue, which will be produced when the routing slip completes. So now let's go and actually post an order and try it out. Okay, we're going to see it wait here. Still waiting, still waiting, still waiting, still waiting. Okay, then it completed. And if I go back in here, it looks like, yep, I received the order submission accepted at the very end of the list. So I waited till the end. I can see that my submit order endpoint received the routing slip completed event, and all of that tied together. So great, that's like totally awesome. I packaged up the details required to respond to the requester inside the routing slip variables, and then used that event that was produced at the end to complete that initial request. So that's given us some composition advantages of how we can use that information, especially the fact that we know that we can decouple the request client into sending them a request message and processing the response message. You know, it's just a two-message exchange. It turns out there is actually a class built into MassTransit that can do this for you. So let's take a look at that, because why would we just write all this boilerplate code every time if we know it's built into MassTransit? The reason I went into that is because I wanted you to see that it isn't magic, it's just a class. Yeah, so we have we're not going to use the request proxy, but we'll use the response proxy. Response proxy, or maybe I need to use both. I can't remember. Actually, I don't remember. I know we have a request response routing slip. I think it's called like routing slip request proxy, response proxy. Yeah, response proxy, and it takes a request and a response. I'm not going to dig into this too much because I really just want to kind of flesh out in the conversation. But if we look at the response proxy, all it's doing is exactly the same thing. It's getting the request ID, the response address, pulling that variable out, checking if it's there, creating the response endpoint, and then, which I think this is right there. Yeah, I should actually be using that. That would make more sense, but it does the same thing. And then creates the response message and pulls it back. Yeah, it also handles the faulted, which is another event that we have to handle. So that's a good advantage of that. And so we can actually just use that proxy as it gets there. We have a type response and we have a type fault response. So we could probably use that. Yeah. So what's our request type? It's a submit order, and our response type is a order submission accepted. And I have to implement the create response message, which I think was down here. Yep. Yeah, see, this doesn't let me set the header. Oh, it's going to set the header for me, so I don't even have to deal with that nonsense. So if I'm just going to create the order message, I can return, yeah, this is where it gets weird because I have the initial request, the submit order request that it expects. Yeah, so we're not going to dig into this too much. We'll go into that later. We're handling the routing slip completed. We should handle the routing slip faulted. I can't remember what it did. What did it do in the faulted case? Oh yeah, it just creates a faulted event. We'll just copy this code out so we have a nice little tasty response here. We're going to add routing slip faulted to this one because we're going to keep this code in our own. We're not going to be tied back to the original thing here. We have the response endpoint. Activity select. Got some link stuff here. We know that the request type is submit order. We didn't keep a copy of the request, so we should add that variable as well. So we'll also add the original request. I'm going to call this the request. Request, and we're going to do just context.message. So we put the request in there. We'll get the request out of there. Request, type of submit order. And it's named request. And then we're going to, let's see, we got a lot of submit order here. So we're going to put this in here. We're going to put this in here. We got the request. We got the response. We aren't going to return that. We're just going to return response because we're going to leave the await there. We're not going to return it at all, actually. And then we're going to do response endpoint.send that fault. Yeah, let's see here. Get response endpoint. What happens if we call get response endpoint? Is that actually available to us? I don't know if that's a publicly accessible method. It is. What's the type I have to pass in? I don't know what the type I have to pass in is. Where's that response proxy? What does it pass in for get response endpoint? Oh, we have a get fault endpoint too. Look at that. How awesome is that? Get fault endpoint of T response versus get response endpoint of T response. So we need the response type, which is our order submission accepted. So we will pull that in. We'll use the get response endpoint. That seems a little cleaner because then I don't think I have to pass the header. I think the header is automatically applied for me. So we'll just go with that. Sounds good to me. Get rid of that one line. Let's see here. We don't need the, oh, we're sending the fault though. That's the thing. That's the difference here. So we're going to say that. We're going to send the response, which is actually a fault. We're going to send fault of that. Okay, so I'm going to change this to get response endpoint since I know what the response is. And then I don't have to push this request ID in here. Okay, awesome. I think we got that going. We didn't need the order ID for that, interestingly. We're going to add one more type in here. We aren't doing faults yet, so I'm not going to dig into that too much. Yeah, awesome. Why did I use the order ID up there but not there? Interesting conundrum. Routing slip faulted, order ID. Where did I use the order ID here? Oh, because the fault does not have the order ID in it. Great, awesome. Don't need it. So I'm producing I'm consuming both the routing slip completed and the routing slip faulted events. And those are just published by the routing slip. But I don't really need to do that because the routing slip events are there, but I would rather know directly versus actually connecting these. I'm not going to worry about that for now. Those events are published. We're going to tie them back in. As we add more routing slips, what we're going to find is that, we can't just publish those out because we need to be able to handle them specifically to our type, because a French fry routing slip might complete and I can't treat it as though it's a burger routing slip. So I need to be able to route those in a specific way so that they don't just kind of go all over the place. Turns out there's actually already a built-in class to do that. I don't think it's created by, but it's in the routing slip request proxy. And I'll just show you that real quick. Routing slip request. proxy. And what we're going to do is we're going to change it to where we add a subscription when we create the routing slip. So subscriptions allow you to add message types and events and specify destination addresses and how routing slip events are processed and passed through the system. In this case, I'm going to add a subscription to say that I want all of the events for I want the routing slip completed and faulted events to only be sent to this endpoint where I'm hosting the consumers that handle those. Because I know that I created the routing slip and I want those routing slip events to come back to this consumer, which I'm going to then handle and use to complete the request. So by adding those subscriptions in, and if we look here in the debug output, you can see that routing slip completed was previously sent to the exchange for the message type, which means it was published. Now, once I've added that subscription in here and I run this, we'll see a completely different thing in the log. We'll see it actually send it directly to that service endpoint. So we'll come in here. I'm actually going to move this over here so we can see the debug log. I'm going to say try it out, execute. We can see it grilled the burger. The burger is grilling. We're going to address the burger. It's going to complete. And you can see that the send now went directly to the submit order endpoint with the routing slip completed message. So we're no longer publishing that event. We are sending it directly to the endpoint that requested it because that subscription is on the routing slip. There's a lot of customization you can do with subscriptions. You can add different message types. You can really kind of tweak them and do a lot of work with that. And we'll do that later in the series. But for now, we're just handling those default events as did we succeed or did we fail? So that's where we're at. We've taken the request client within the controller. We've stuck with that request client metaphor for the HTTP request. And we've now taken what was handled in a single consumer and broken that out into two separate activities within the routing slip that run independently, complete consecutively, and use the output of the first activity within the second activity. So it really gives us, another atom or another construct to be able to process messages without putting all of the logic into a single consumer or anything like, other stuff like that. So that's kind of what I wanted to cover today. I'm looking at my notes here and see if there's anything I wanted to dig into. If there's any questions, be sure to throw them in the chat because I can definitely bring those out. I'm kind of behind on the chat. It looks like there was some comment about, some comment about a transport that's out there that we don't support. Let's see here, timeout for a request. Again, we aren't really dealing with the timeout issue at this point. The request client is going to time out if it takes longer than I think the default of 30 seconds. We could certainly specify a deadline in the routing slip based on that time to live. So if we wanted to do that, we could look at we could look and see, because if this was a request, it might have an expiration. If it was just sent to the endpoint, it won't have an expiration. It's just a command. And really, you probably shouldn't time out your orders anyway, but if the person leaves, so on and so forth. We're adding the order ID. We can actually look at the context of the message and see if it has an expiration time. And if it has an expiration time, we could do something like builder.add variable. And we could even just put expiration time, or we could put deadline. It really... the terminology, deadline makes sense in that, it isn't using the same word as the message header, and it lets me know that I want that. So I can just do expiration time.value, and then I have the deadline in there, and I could find out that if messages were backed up and the grill was backed up and the person wasn't going to wait 15 minutes for a burger, that we could just cancel that back out. So we could capture that to handle the request, and then because that's in there, we could check the, then within the routing slip completed event, we could actually just go and check and say if it has an address, and we could also pull that, we could check that deadline if it's present. I think because the other one is doing context.message. Is there a try get? Has variable, contains, I can't remember. what that was calling. I want to say it was calling response proxy. Oh, it was actually looking at the dictionary to see if it had the value. Because I think if you call get variable and it isn't there, I think you get an exception. So we could certainly look and see if the variable contains the key for the deadline. And if it does, we could check that deadline. Oh, we could check that if we wanted to and only respond if the deadline hasn't passed. We could just say if deadline dot is less than or equal to datetime dot UTC now. What is deadline? Oh, we have to get the correct type, date time. And we could say that if it's that, we just want to return. We aren't going to actually send anything back. Yeah, a comment in the chat was it's kind of like checking a cancellation token. That's exactly what we're doing. We're saying, hey, the deadline for this is 30 seconds from now. If you aren't there, don't bother responding because I'm not listening anymore. So we could do that kind of deadline check. And this is something that we would probably, as part of a consumer of MassTransit, this is something we would probably throw into our commons file to just have an ability to check the deadline. And I think as we refactor this, as we go on and start adding some additional routing slips, we'll see that we'll take some of these methods and put those into our own common classes so that we can use them. Just as we kind of build our own plumbing or glue around the framework to kind of give us the capabilities without, we can't all just go modify the MassTransit source code to behave the way we want it to. We have to, adapt for it. And I'm trying to take that perspective with this versus just assuming I have to go fix something in MassTransit to make it work the way I want it to today. Because everybody has different perspectives and different biases. So that's another piece on there. And I think what we'll see is if we want to set a breakpoint on that and actually look at that when that comes in, the request client does set a default expiration time, I believe, of 30 seconds. So when that does land, we'll see that come in with that 30-second delay. And we'll see that value get added. So you can see expiration time does have a value, and it is 4:32:43 p.m., which I'm assuming is UTC, because all the base timestamps in MassTransit are UTC by default, because I believe in UTC time. Datetime offset is for when you need to know when something happened within a particular location, but if it's independent, I keep all system timestamps in UTC. So we'll just go with that. We wasted 20 seconds of the request time, so it might actually get to the point where it just discards it, actually. So if I caught it in time. I don't know if I did. Oh, looks like we've already completed that one. So let's try it again. Let's go ahead and execute it again. We're going to sit here for, what's the expiration time? Let's see, 32. Okay, I'll watch the second hand. We're going to burn some air time here, but that's okay. Because we know it takes 5 seconds to grill a burger. So with the expiration time of 32 seconds, that means we have to wait about 7, 8, 9, 10, 11, 12 more seconds. Okay, now we'll hit go and actually send this routing slip. And I think what we'll see is over in here, we will probably get an error. Yep. So we're going to return. We aren't going to send the response because we know that the deadline has passed. And if we go back to the UI, we get that 500 internal server error, timeout waiting for response. Now, that's an exception that we could handle in the controller to return something prettier. But for our case, we get to see the nice detailed error. Yeah, so that was a good question. Let's see here. More generally, when should you choose to use routing slips versus state machines? What's the questions to ask? That's a good question. State machines and Sagas in general are about managing state. And as we discussed earlier in the series, a routing slip is really using the network as state. We're keeping the state in the variables of the routing slip, so we're using the durable message broker to actually transfer that state along with the message. So it eliminates the dependency on a database for the distributed transaction. Good. It eliminates the need to go back to a central coordinator to update that state. Good. But it doesn't eliminate the ability to have state. And we are going to, I think it's in I think once we get around to the episode 6-ish time frame, we should start, when we start to have multiple routing slips running and we have to basically start to join. We're going to bring state machines actually in, and we're going to have, we may use state machines, we may use a mix of state machines and consumer Sagas to do those distributed joins as those different routing slips complete, and we try to fill out that tray to complete that order. So that's a huge thing, and I think they work well in combination. Again, the Sagas in MassTransit, they tend to fit more into the process monitor category of, you know, business component, whereas I think routing slips are more for the original Saga dream of execute and compensate. And I think in the next episode, we're going to handle compensation and fault handling. We're going to make it so that, you know, if for some reason we can't dress the burger because we're out of mayo, then we're going to kick that back and compensate that routing slip and show how we can do that. But yeah, I think they're complementary. State machines are great for when you just want to track state. And doing things like fanning out, where you have two different things you need to do, or you need to have some checks and balances based on events coming from other systems. That's where a Saga makes more sense. Routing slips should be treated as a single business transaction that has multiple steps where you want to be able to support compensation. So if you see yourself writing a consumer method to consume a message, and you're calling like two methods in it, and if the second method throws, you have to have like a finally catch to clean up from the first method, that's when going into using a routing slip might make sense for you. Another question or comment in the chat was, one big thing I observed around people using routing slips is they didn't realize that each activity has a queue. Yeah, so if we go back and look at the RabbitMQ setup here, we can see that when we go to queues, each activity has its own queue. Right now it has an execute queue because we aren't doing compensation yet. In the next episode, we'll add compensation, and you'll see a compensate queue. And the reason for that is routing slips are one message type. Routing slip. There's no type-specific information that the originator of a routing slip needs to have to couple to the consumer of the message. Whereas with a consumer like submit order, it consumes the submit order message type. And I'm now going to unbind these because I can do that, and I'll do that in the next episode. The submit order message type means if someone publishes a submit order, it gets down to that endpoint. Well, the only message type that dressburger execute listens to is none. There are no bindings because it only supports a routing slip being directly sent to that endpoint. If we bound this to an exchange and someone published a routing slip, which would be really annoying, and none of the infrastructure internally will do it, then every activity would get it and think it was supposed to run. Because again, routing slips contain all the routing and itinerary, the routing information for the activities in the itinerary. And if we go back to where we're building that routing slip, you can see that we're using our formatter to name the execute activity to get the queue name, and then using a short queue name to actually address that activity in the routing slip. So those addresses are resolved at runtime based on those short names as it tries to send and complete each activity. So those really kind of compose together. There is no coupling of types or anything between routing slip builders and the actual activities executing the routing slip. Okay, so that's what I wanted to cover in episode 3. I'm going to take a little break. I'll probably come back with episode 4 shortly once I get my head together and get a drink of water and cool down a bit. But yeah, so I think we covered a good kind of completion of the previous episode of how we track that routing slip and keep it within the request. Appreciate y'all joining, and we'll catch y'all in the next one. Thank you.